This topic is about the importance of arc length and travel speed. It's important to have the correct arc length and the correct travel speed. This is an example of both kind of in scope. The arc length is less than the diameter of the electrode, and the travel speed is such that it provides a little bit of reinforcement, but it's not built up too much and not crowned up a whole lot. We'll take a look now at an arc that's too long. That's the biggest problem when you're learning, is using too long of an arc, because the rod is continually getting shorter by burning up. It's violent, it's loud, there's a lot of spatter. You know, you can actually get away with a lot in the flat position on an arc length, but you need to learn how, while you're welding in the flat position, learn how to hold a tight arc, because when you get out of position, it's very important. Let's take a look at too slow a travel speed now. I'm just creeping along here, barely even progressing. Now this is going to actually make a decent looking bead. Problem with it is it just wastes time, it wastes material, puts a lot of heat into the part, and can cause excessive distortion. The bead doesn't look that bad, but it's piled up more than it needs to be. The other extreme, and talk about travel speed that's too fast. And sometimes you want a travel speed that's fast like this. If you're welding something really thin, you want to just zip along, but normally that's too fast. It's going to provide too narrow a bead, and you can actually miss the seam that you're trying to weld. Let's take a look at using too low an amperage here. See, it's barely maintaining an arc, a very cold bead piled up, not really melting the base metal like it should. Rod's sticking. It's hard to maintain an arc. It's hard to distinguish puddle from flux and slag. Not a good looking bead. Amperage too high. This is especially a problem if you're welding out of position or on something a little thin. Now I have switched to a little bit thinner metal here just to exaggerate it. You see how far the puddle is hanging back behind the arc. It's a really super long elongated puddle, and here at the end, boom, blows right out. Using too much amperage, you can't control it. This topic is striking an arc and welding short beads. I'm going to be using 6013 1/8 diameter rods at around 115 amps. Going to be welding on 1/4 inch thick material. That's roughly 6 millimeter thick material. And it's a good idea to scribe lines or draw lines with either soapstone or a silver pencil, so that you have a nice crisp line to follow, just as if it was a weld joint. Let's get ready. Strike the arc on the edge of the material just like you would strike a match. Try to maintain a fairly tight arc length. When I say fairly tight, I mean the diameter of the electrode or less. That's the core of the electrode, so that's 1/8 of an inch. Arc length can be deceiving. It's usually longer than you think it is because the wire is burning off up inside that flux. We're going to reverse the direction now, go different direction. That's a good idea. You don't want to get locked in to always going left to right or right to left, because you will have to know how to go both ways. So just changing the direction here, everything else is the same. When I come to the end, I'm going to back up momentarily to fill the crater. Swap directions, go again. You will have to cool the piece off maybe every 3 or 4 beads. And save this piece when you're done, because you can fill these gaps in between the beads for extra practice. Inspect your beads. Make corrections as necessary. You know, ask yourself the questions like, was my arc length correct? Was my travel speed okay? Was my angle of my rod okay? Make corrections, keep